0, and liftoff of Endeavour.
Houston now controlling.
We're building something that hasn't been built ever in the world before.
To be able to see something like this, say, in 50 years and know that you were part of the beginnings of it is going to be crazy.
It's an incredible project here, you know, a NASA competition, it's NASA.
This is $2 million, it's a lot of money.
80 watts in 3, 2, 1, beam is on.
If you can somehow actually build this, access to space would be an everyday thing.
I'm 100% committed to winning this thing. I don't think there's any going back. This needs to work.
We're starting to feel the stress and strain.
It comes down to that last run, it's do or die, and we just want to be able to place first.
Since as long as I can remember, the team's had discussions about can we actually do this?
Now it's our chance to perform.
The pursuit of knowledge and understanding is like the creation of art. Both owe a debt to imagination. How will science improve our world? What discoveries will be realized, not by providing the correct answers, but by asking the right questions? Welcome to Mindfield. For as long as man has recorded his ambitions, he has dreamed of reaching the stars. The Tower of Babel, Jacob's Ladder, even Jack and the Beanstalk reflect our fascination with the heavens and our desire to reach into the great beyond.
10, 9, 8, 7, 6, 4, 3, 2, 1, 0, and liftoff of Endeavour.
For the past 30 years, NASA's space shuttle program has relied on rockets to gain access to space. But the astronomical cost of fuel needed to leave the Earth's atmosphere is the driving force behind the development of new methods to reach space.
We will increase investment right away in other groundbreaking technologies that will allow astronauts to reach space sooner and more often, to travel farther and faster for less cost. That means tackling major scientific and technological challenges.
Space Shuttle Atlantis now comes home to the Kennedy Space Center for the final time. 25 years, 32 flights, and more than 120 million miles traveled. The legacy of Atlantis now in the history books.
With the United States' entire space shuttle fleet scheduled for retirement in 2011, NASA is challenging engineers around the world to develop innovative and original proposals for space access.
And step by step, we will push the boundaries, not only of where we can go, but what we can do.
It is a process that allows anyone from science, industry, and education to contribute to the future of humans in space.
It was back in 2005, January, NASA just announced the Centennial Challenges program. So that was a bunch of money that NASA was going to put throughout different areas that they were having problems in their research. They picked a few really exciting competitions that they figured could spur imagination and draw out some actual real engineering projects. That's pretty much when the USST, the U.S. Space Design Team, was born.
The University of Saskatchewan Space Design Team began to develop what may be the future of space access: the space elevator.
I hadn't even heard of a space elevator or what it was. This concept of going up there on a string pretty much into orbit, it was a very interesting concept.
So the basic idea would be to take a string and tie it to the Earth somewhere near the equator, and then stretch it out for 100,000 kilometers and tie the other end to a rock. If you can somehow actually build this and get it set up and out there, then that whole assembly just swings around the Earth like a ball on the end of a string. And then you can run elevator cars up and down that cable as slow or as fast as you want. One huge challenge is actually building that string so that it's light enough and strong enough to support the whole assembly. And then the second challenge, which is the one that we're working on, is how do you actually get power to these elevator cars when they're 10,000, 20,000 kilometers away?
Faster, Jordan!
Imagine you have to pull at 5 meters per second.
Since 2005, the USST has been developing a power beaming system that uses laser light to power a small elevator car along a vertical cable.
When we first started this competition in 2005, people would actually laugh at us. Like they didn't take us for real. Like, you know, we would go out to get sponsorships or order parts, for example, and you tell them what you're working on a space elevator project. They'd literally laugh at us. It wasn't until the second competition in 2006, when we won it for the second time, that people actually took us for real and realized what we were working on.
Since the Space Elevator Games began, the USST has been the team to beat.
We set 6 world records in those first 3 years, 4 which are still holding, and this year's competition, I think we're going to again set more records and hopefully take away this prize money. So.
NASA sets a minimum criteria. To win the $900,000 prize, you have to climb this 1 kilometer cable at 2 meters per second. And we're shooting to climb at 5 meters per second to win the $2 million prize.
The stakes are high, as always. There's a lot of pressure on the team to win. It's different in the sense that now I think we're actually expected to win.
They're not problems, they're opportunities.
I got involved in 2007, before the 2007 competition. I got snagged in by these cool ideas to work on the high-power laser optics and stuff like that. So that first year I spent a lot of my time on the design of the laser system.
Yeah.
Mark Boots is a physics master's student at the University of Saskatchewan. Between his studies and volunteering for other student groups, he spends most of his time working with the USST.
Yeah, it's a lot. My girlfriend's a little bit lonely sometimes.
That's what we're looking for. So, okay.
This year I've taken on way more of a project management role, and sometimes it's actually kind of weird to be like completely stepped back from the technical design side of things. But I think that's what the team really needs from me this year.
The general point is that the more efficient we can be, the more advantages we'll have as far as getting in testing time.
Mark's, yeah, definitely one of the main reasons why I joined this team. Just hearing him speak is absolutely amazing. He can think of the most complicated things, but he can almost bring it down to anyone's level.
So this is an aluminum front surface mirror. Just like what's in your bathroom, except it's about 1,000 times more flat. And it has the aluminum surface on the front rather than on the back.
I haven't met a guy who has an answer to everything. It's a great opportunity to work with him and learn from him.
Just one of the better guys that I've ever had the chance of meeting.
Rylan, are you working on a system? Like, are you guys going by row and column? Can I grab that bolt for Doug to take with him? Sorry, buddy. Do the different timings change anything? We're facing this huge, massive, complex issue, and so we've broken it down so that every person has a little piece to worry about. And I think it's my job to understand the whole thing, and especially how all those pieces fit together. Sometimes it means being an electrical engineer or helping with the computer coding. Sometimes it means pretending to be a mechanical engineer, but hopefully I can work with all those teams and figure out how the whole thing fits together.
For the past 5 years, the University of Saskatchewan Space Design Team has been the frontrunner at NASA's Space Elevator Games. In that time, they have set several world records.
you know, being at that very first meeting when this team began to how far it's progressed now is really, really amazing, and to see how far the team has came in the last 5 years. So
Clayton's kind of like the grandfather of the team. He started the team with a couple other guys back in the early days in 2005.
In 2005, the challenge was to build and develop a robot that could climb a 50-meter tether at a rate of 1 meter per second. We had nowhere to start, so we just really started playing with Lego and coming up with ideas, drawing on the chalkboard, brainstorming, and that's where it really started. So.
How far do we have to go to beat UBC?
We were the only team that actually moved on the cable.
Yeah. Come on, guys. Bring on.
And that was our big accomplishment for 2005, is that we moved.
So we placed first, but we didn't actually win the prize money because we didn't meet the minimum requirement.
And in any minute, they're going to get ready and shoot up. Hopefully we see it again. So get your cameras ready.
In 2006, the minimum requirement was to climb 100 meters at a minimum speed of 1 meter per second in order to win $200,000.
Keep moving.
We'll get the official time here and see.
We came within like a hair of winning the competition.
We were just 0.04 meters per second away from winning the prize money.
They actually had to remeasure the cable to see exactly how long it was to see if we'd met the criteria or not.
And then in 2007, the speed went up to 2 meters per second.
We were one of 2 teams that showed up with anything resembling a laser power beaming system. We had the design done, and it was a really solid design, but it wasn't built yet. We spent a week down at the competition site in advance, scrambling to get stuff put together. On like the last possible day of competition, with like the last 2 hours left, we did our first climb, and basically like everything fell into place and worked like exactly as it was supposed to.
Our temperature is good, it's 14 degrees.
Keep her chalky.
Come on, guys.
Yes.
Come on, guys.
Come on.
Oh, come on.
Go.
Oh, come on, guys.
Please.
Come on. Do it.
And we climbed at 1.86 meters per second, and the target was 2 meters per second. We actually did 5 climbs within that hour. Every run was like almost exactly the same time as the last, and just like super short of what we had to do. As soon as the climber came down on the last run, we realized why the climber wasn't going as fast as we expected it to, and simply switching a gear out and changing the gear ratio in the drivetrain would have let us go twice as fast. We were the first place team and a world record setter, but like just an inch short because we were 2 hours not prepared enough. My job is to make sure that doesn't happen again. If we thought the stakes were raised in 2007, this year we have to climb 10 times higher and 2.5 times as fast as we did that year.
The other competitions, while they've been greatly important, they've almost been building up to this year. The requirements are that much higher, and this is actually comparable to the actual application that this technology could be in.
And then each one of these bends, we did individually by hand. And then there's around 400 fins on this paddle. And then plus...
John Steeves is in his 4th year of mechanical engineering. The USST was quick to capture his imagination.
It instantly just caught my attention. I went home and told all my friends about it, like how sweet this thing was. They obviously didn't care too much, but it was good.
He's got one of the biggest commitments to the team I've seen too, and he's always there to do something when no one else wants to do it.
I'm 100% just committed to winning this thing. I've put off a lot of my other activities outside of this. We're building something that hasn't been built ever in the world before.
To wirelessly power their climber at a 1 kilometer distance, the team has been developing a process called power beaming.
Besides the actual space elevator, power beaming technology is very significant for many industries. You can transmit power to any location wirelessly, and you can be at the most desolate location, so in the middle of the desert or Antarctica, and have a laser power your station or even your vehicle, a mobile unit, without having any cords or anything connected to it. So the possibilities are pretty substantial.
An industrial-strength laser serves as the cornerstone for the USST's innovative power beaming system. The laser cable is attached to the C-can, a specialized shipping container that serves as the team's operational hub for all systems.
So the walkthrough on our system starts out with this 0.1 millimeter fiber carrying 10 horsepower of light coming from the laser unit. When I think about 10 horsepower, I think of like an aluminum fishing boat on a lake in Saskatchewan. That's a lot of power. We have that much power coming out of a 1/10 of a millimeter optical fiber. That comes in, and the first thing it goes through is our optics. The job of the optics is to take the beam that's spreading out from the fiber and collimate it so it's going as straight as possible. That bounces off of a mirror, and the idea behind the mirror is that we'll be motorized and move to let us track the target so we can always keep the beam pointing right at the climber as it moves around and shakes on the cable.
And now once it hits the climber, the underside of our climber has solar cells on it, very high efficient solar cells, which will turn the 8 kilowatts of laser into electrical energy. So once that electrical energy is sent through all our motor controllers and all of our complicated electronics, it will be turned into mechanical energy through the motor, and that will be turned into motion up the cable.
At this year's games, the cable will be suspended from a helicopter, creating a racetrack higher than the tallest building in the world.
Our laser system has to be extremely accurate. It has to be as accurate as having a laser pointer shining at a 747 at its cruising altitude and hitting the window.
Hopefully the end result is that this system is like leaps and bounds better than what we've had before. It can meet NASA's criteria and also hopefully leaps and bounds better than what anybody else has built.
There is 1 month to go until the Space Elevator Games. And in true fashion, the USST is scrambling to get their designs finished and working. But before they can attempt to reclaim their first place title, they must travel to Dryden Air Force Base, California, to test their system.
One thing that we haven't had in the past that we have now is this test. So if we go down there and there is a problem, we can always come back and we have a month to work on it.
It's allowing us to show our hand about a month early and get our stuff worked out and all the bugs kind of taken care of now.
So we have to show that our climber is going to be structurally rigid, and when it's going up the wire, it's not going to melt or start falling off.
The team needs to leave for California in 12 hours.
We're basically still on the middle line, and everything below here is supposed to come together before tonight. So
what happened was, what really set us back is our solar panel. We've had a bunch of electrical issues with that.
The solar panel powers the climber by converting the light energy from the laser into electrical energy for the motor.
The panel's made out of 1,080 individual cells that we had to handle and process all on their own. And this is designed to fit into the little pockets in this panel. What happened, like any hand-built thing, nothing ever lines up perfectly. So we found out that these wouldn't actually fit in between the rows that were created for them.
Essentially, yeah. Every time we try to mount a solar cell onto our panel, it'll touch one of the metal strips and short out. And we can't have that happening, otherwise our system's completely useless.
Over the last 2 nights and days, Andrew's been going over his baby with a Dremel tool like a surgeon, strategically removing bits and bits of metal where everything has to fit. So
it's a trade-off in efficiency. We really wanted to keep everything tight and close together so we get as much laser concentration as possible. But at the end of the day, if you can't build it, it's not worth anything.
Andrew Williams is the leader of the mechanical side of the USST. One of his major projects has been overseeing the design and construction of the climber's solar panel.
When I started out in engineering, I had debated the aerospace side of things. Always been fascinated with NASA's angle of what they do and what is possible out there.
Andrew's been around for a long time. He graduated the year before I did, so he's a graduated mechanical engineer right now.
He just knows everything there is to do about machinery and mechanical components.
He's probably one of the hardest people to work with, and at the same time, one of the most valuable people to have on the team.
Him and Mark definitely have some heated discussions.
I'll get really frustrated with Andrew, and then I'll think about what he said, and then a couple days later, I'll be like, yeah, I think he actually had it right.
I don't know if you'd define it as butting heads.
So then I'll go back to him and be like, I think we should do this. And then he'll be arguing me from the other side. And I'm like, Andrew, I agreed with you. I thought about it. You were right. Let's do it.
I think we take different perspectives to every problem.
It's more of constructive debate leading to a better way of doing things, hopefully. Yeah.
He's always providing a really critical viewpoint, and I think that's really, really valuable to examine whether we can do this, whether we're working on the right thing, whether it's realistic, those kind of questions.
So we gotta put that in, home it real quick, take it out, put the mirrors in.
With less than 12 hours remaining before the team needs to leave, things are still moving slowly.
Down to the wire.
Yeah, this weekend was pretty hellish for some people, I think. 48 hours straight.
I love it and hate it. I love the work, I love what we're doing, but it's just that much work is not good for one person.
While work on the solar panel continues, Mark checks in on the progress of the motor.
These guys are feeling pretty good. Shay got the motor working really well for the first time today. He started this project about 9 months ago, thinking it would be a really quick, 1 month thing. Almost figured out, but he's finally hit some major milestones, and he's feeling pretty good. So.
Today was a good day in the sense that, before you would ask me a couple days ago, I would have been pulling my hair out. Today I made a lot of progress here on the motor end, on the controls and some other things as well. It looks like a simple design, but it's all what's needed, right? Why build something bigger when you don't need it to be big?
Shay is by far the most dedicated guy that I've ever seen put his mind to something.
He essentially has designed something that hasn't been created in the world yet.
Moves at what? It moves at around 3.5 kilos. Oh wait, about 4 kilograms.
Okay.
There's a lot at stake there with going, if we can get a more efficient motor, we're looking at efficiencies in the 60 to 70% for last year for our motor side of things. So my mandate to the team was to say, okay, let's get a motor together that is reliable and is in the 90s%. So far, it looks good that we'll be able to achieve that.
The motor will be attached to the solar panel and will use the converted laser energy to climb the 1 kilometer cable.
So we'll do a test here at around 80 volts, which will be our operating point.
You all clear? Yep.
There. We're on 2,700 RPM. This goes about 10 meters per second of linear motion. But 3,600 RPM right now.
How's everyone's ears doing?
I don't know, I admire his dedication, but I feel bad for like the torture he's gone through putting that thing together. I know the payoff's gonna be worth it.
Feels like we've been under the gun working on this project since, since summer of last year.
But I know that in the end, when this thing does work, it's gonna feel like this massive accomplishment for him, so.
Meanwhile, work on the solar panel is still behind schedule.
We've probably put in, I think it's around 400 hours into that panel. And to get those hours back would be just unreasonable to expect.
We need to push the time frame on the panel no matter what. I think we should commit to it. Just commit to trying to get it as done as you can do without cheaping out or rushing it.
But again, the mechanical side's getting shorted because there's analysis that we'd like to be doing in the field.
Well, tell me about it. There's tracking analysis I'd like to be doing too. There's a whole bunch of other stuff that can't get done because we don't have the pre-stages yet.
We're starting to feel the stress and strain. The long hours are starting to get to a few people.
Some people need to get to work if we're going to get out of here tomorrow morning. So I'm going to go with John and start packing up. Anybody that's not working on the panel, can you guys help pack?
Won't be much sleep tonight, that's for sure.
After many sleepless nights and round-the-clock work, the USST prepares for the trip to California to test their design.
That trip was actually at the end of a pretty intense and crappy week.
We wanted to make a showing with a complete system and really get the most value out of our trip so that we could actually put a laser to the panel. We soon realized that we weren't going to have the panel complete in time, and qualifications of the laser system was equally important.
So we decided we were going to send down a minimal core team of 4 guys to go down and set up.
The skeleton crew makes the 30-hour drive to California to the competition site.
The urge to want to get out and stretch was high, but it's not recommended when you do it at the gates of a military base in the middle of the night, carrying a large payload behind in a truck that looks highly unusual. Hands were placed on sidearms, let's say.
So starting about 10 o'clock in the morning, we got out onto the lake bed and found out that everything had to be off the lake bed by 3:30, and that was going to be our entire time to test.
That was kind of a shock because we thought we'd have 2 days of testing.
So that definitely sped us up a little bit as far as what we wanted to do and what we had time to do.
The 4 guys that were down there had the challenge in 40-degree weather of trying to assemble this system that's just been shipped for 36 hours across the continent, get everything ready to do laser testing, and then pull off any kind of meaningful tests before packing up again in 5 hours. Nathan and Andrew and I probably yelled at each other a lot that day.
We ended up finding out something that we didn't know, that we had to be cleared by NASA in order to do the competition, to actually be able to compete.
We didn't realize that this was like a mandatory qualification test. We thought it was an opportunity for teams to test their stuff before the competition, but we didn't realize that they were going to make decisions at that point whether you could compete or couldn't compete.
We're really surprised at that and quite nervous because we were counting down the time. We had less than an hour left at that point.
We had a major water system leak, and the guys from Trump, the laser provider, were like, okay, aren't you guys shutting down for the day? And we're like, okay, we've got 4 minutes. Let's see if we can figure this out. We found the leak, we filled it, we like resealed the plumbing, and got the laser up and running. We ended up getting about 2 minutes of laser testing in, enough to prove that the optics weren't going to blow up, that they were actually going to stay cool, and we could see our laser beam a kilometer away.
One of the officials from NASA said that he saw enough of our system and the organization of the team that he had enough confidence in us that we would, in fact, be able to compete. Otherwise, who knows?
In that regard, it was a very successful test. On the flip side, it was 70 hours worth of driving for a half an hour of laser time, which was a little frustrating. There was a lot more testing that we would have liked to have done, using the laser off the mirrors to see if they're going to crack or fail, integrating that with the gimbal to see how accurate our GPS tracking is going to be. Things like that we would have liked to have done, but that's why we're getting ready tomorrow for our field test here in Saskatoon.
I know we don't have everyone here, but the whole idea of this meeting here is to, when I was talking to Mark, was to get kind of like teams set up.
They'll help unload the sea can and set up the trailer. That will basically be one team's job.
The rest of the team pitches in and finally finishes the solar panel. The completion of the panel is a huge milestone for the team, but much still needs to be done before they're competition ready.
So today we're out here, a couple kilometers out of town, where we've got a big open space to test out our tracking system for the first time.
Today we want to just get as many systems running together as possible, so integration of our tracking, our GPS, communication to all systems, and just be like a well-oiled machine.
It's tough to work a 8 or 9 hour day, then go back to the school on your summer vacation and work on some stuff. But we're doing it, and they got a good crowd out today, so it's obviously working somehow. So. Last summer, my role was to do fundraising and reach our budget goals. Now I'm helping out more with the design and everything else.
Pat definitely has grown a lot with the team.
Actually, the first few times I heard him call sponsors when we were working together in the office last summer, I was like, oh no, it's a train wreck.
Yeah.
It was actually really neat over that summer. By the end of the summer, I turned to him after a phone call and I was like, Pat, you're getting really smooth. Like, he'd really developed some like interpersonal skills through that.
Yeah, so this summer I went to move to Calgary for 4 months for my summer work term. It's hard being away from the team, and especially when we're so down in crunch time now.
Downrange, this is CCAN. We see you. Over.
Today we're doing just some tests, making sure our systems all work. Right now we're just starting up the tracking system.
Our goal is to test all the systems integrated together and see how well we can track the climber as it goes down a road, swerving back and forth.
The little target on the road there, so that's actually our GPS station.
The point behind the GPS tracking system is somehow we need to know where the climber is so we can get the beam from our ground station back onto the climber as it's moving around and climbing the cable. And it uses multiple antennas to solve the GPS problem better than a single handheld receiver. So we actually know where the climber is relative to our base station with an accuracy of about 1 centimeter. If we can do this, then we know that the tracking system is at least a proof of concept, and we can test all of our other communication links and electronic systems at the same time.
The test is successful. The GPS signal is accurately tracked by the camera. For the competition, the GPS will need to track their climber vertically for at least 1 kilometer.
Somewhere around 1 kilometer. How'd it go?
Geez, Dawson, that's 1 kilometer and 3 meters. And 42 centimeters, just in case you wanted to know.
You want to continue or come back?
Might as well come back.
Was it tracking while I was moving, or?
Oh yeah.
Pretty good?
There's some lag. It was like maybe 1/4 of a second behind you or something like that. No, that was encouraging. It actually didn't take very much at all. Like, we weren't tracking with like 2-inch precision, but it didn't take much at all to tweak the calibration to keep it on target, so.
While the GPS tracking was successful, the complete system is not fully functional.
Right now, we actually are having some problems with some of our motor controller and electronics.
Electrical team wasn't even ready at all, so they've been working on it all day, and they just got here an hour ago.
Well, right now we'll be in a motor, kind of more so on the motor test side of things. We had some issues with communications with it.
They're calling it ready. They say it works in like bare bones mode. I'm not sure what that means. They can get the motor to go on and they can get the motor to go off, but not with like the controlled structure that we're supposed to have.
Last night we were up debugging stuff, so I got about an hour of sleep between 8 and 9, and then again here from about 3 to 4. So I got my 3rd or 4th win, so I'm good to go again.
We said everything had to be done today. Today was our trip date. If it's not done and not working, we're not going to be ready. We're not going. So it's a whole different story, trying to manage a team of volunteers that are just doing this because they want to have fun. So.
It's been a long day and night of testing, and Mark is frustrated with the team's slow progress.
For whatever reason, it's impossible to hit deadlines. If it's not done and not working, we're not going to be ready. We're not going.
Yeah, you can definitely tell when Mark's feeling the stress. I think he definitely feels a lot of pressure for this competition.
Every time we do a test, we find out something else that's not working. So we haven't yet done a test where everything's worked as planned. There's the idea that you can work on this component and I can work on this component, and we can both say that they're done. But when you throw all these together into one big complicated system, you still find errors that are created between the components.
Holy crow. There's a bunch.
And that's something that I think has been a bad attitude that's been developed in all of our software coders from what they learned in school. So you do a computer science assignment, you have to turn in a program that does this. You write it, you get it back, and you got 80% or 90%. It's like, that's a sweet grade. But really that means that the program wasn't flawless. You showed some of the ideas you were supposed to, but it didn't do what it was supposed to do, like flawlessly, reliably, every single time. And that's the thing that we need to provide.
How long?
I don't know, not substantially longer, I don't think.
Unless it's 100%, it's not done. And that's an attitude that people haven't really developed in school.
At this point, like, we know it's going to have to be the whole group working on that stuff. There's not really one person we can make accountable for that. Anything else?
There are just 2 weeks until the games. The team is getting one last opportunity to test their systems as NASA holds a final testing round in California. With work still to be done, the USST makes the trek down to the competition site, hoping to get their system fully functional before the games.
So that trip was our second chance to do qualification testing. We only had 2 minutes on the first trip. So we were back down there to test out our laser system on the range at the NASA test base.
The test began well, with the team optimizing their laser optics and tracking system. They also had the opportunity to test their solar panel against the fully powered laser. Many months of work were on the line. The panel performed perfectly, handling the power and staying cool under 8 kilowatts of concentrated light. But then, something unexpected jeopardized the future of the games.
To do the climb, we need a 1 kilometer vertical cable, and the plan was to hold that up with a helicopter on the top and a winch on the bottom. Apparently, holding up this 1 kilometer vertical cable is a challenge even for the NASA team. They may have set their own criteria too high. The helicopter took off, pulled out a whole bunch of cable from the spool, and then dropped down a bit and developed a bunch of slack on the ground. As soon as they yelled at him to go back up to altitude and take the slack out, he jerked the cable a bit when he pulled it tight. They would have snapped the cable, but instead they had a safety link at the top. So they pulled out the safety link with about 3,000 pounds of force, and the cable and the whole assembly came falling down from 1 kilometer. We actually had our GPS tracker up at the top of the cable so we could track the helicopter, so that's in several pieces now as well. But the cable landed on some vehicles, caused the safety incident. No one was hurt, thankfully, but NASA's having to investigate that all and develop a new set of procedures and a safer helicopter system. We're in a holding pattern until they figure that out.
The Space Elevator Games have been postponed indefinitely.
I believe the biggest hurdle has been actually getting down to this competition.
I think one of the most discouraging things for people's motivation is to gear up for a deadline that they know is going to happen and work their butts off for it. And then that deadline arrives and the competition gets postponed or something like that. You're a little bit deflated. All that energy was for something that didn't need to happen, and then people are really bummed out for a couple of weeks after that. When you originally envisioned working on this project for 6 months or something like that, now it's 1.5 years later and you're still working on it. It takes a lot of dedication to keep going.
After a safety incident during pre-competition testing, the Space Elevator Games are on hold. The USST is on standby until a new competition date is announced.
We've got some time, but I think we actually really needed it. We were at the 97% done point, which, like we talked about, unless it's 100% or 110% reliable, it's not going to work when we need it to. So the next few weeks are going to be to solve the last few problems that we've got and to test everything extremely reliably and go through every little piece and find the things that break just once in a while and try to get those all worked out.
Stop the testing, and the main competition begins on Wednesday, November 4th. You can follow the competition on the USST website.
3 months after the games were postponed, and 1.5 years past the original scheduled competition date, the Space Elevator Games are finally set to begin.
But last night, Friday, we left at about 5:30 from Saskatoon, and everything was going well. We've only had a couple stops and no big delays.
Oh yeah, Pat forgot his passport. After telling all of us to make sure we had ours, he forgot his passport, so they did a 45-minute trip back home to pick it up.
Oh, no, I don't want to mention that at all, actually. We're about 1,400 kilometers through the trip and 17 hours in, so looks like we'll be getting into Edwards at about 1 o'clock in the morning if we keep up the pace.
I'm a little bit stressed. It's going to be like go, go, go as soon as we get down there. They're trying to push all the setup forwards because they took a day off the end of the competition. So it's going to be a real scramble, and I'm just trying to figure out how we can get everybody organized to do that. We can rest when we're done. We got a week to go, so.
Yeah, we're thinking since we're so far ahead of schedule, we might take a supper break in Vegas and, you know, go eat some cheap buffets and see the sights a little bit, so.
The bright lights and flash of Vegas provide a small distraction for the USST. The next morning, the team will begin the final 300-kilometer drive to Edwards Air Force Base for the Space Elevator Games and the $2 million prize. Next time on Mindfield.
Definitely something to, you know, be proud of, that we're competing against professional laser engineers.
Hopefully the end result is that this system is like leaps and bounds better than what we've had before.
We're running out of time, daylight time.
Trying to get him airborne in 30 minutes.
Tomorrow's going to be our first shot at real competition.
They're #1 right now. We don't like that. We've been #1 all the other 4 years, so we want to keep that title.